What's up, Calc gang? Welcome back to some mechanics. So let's solve this problem, right? We have 3 titanium rods, and you can see in the picture that they're kind of just, there's one 6-kip force pulling on this beam, and then it pulls on those 2 rods. Now our goal is to find the horizontal displacement of this point here, F. We're going to see how far this way it goes. So we're also, in the back of the book, you find the modulus elasticity and titanium rods. So let's go ahead and solve it. So I'm starting with this force body diagram here. I already got it started. So what we need to do is we need to find the force in each one of these 3 rods so we can find the displacement of each one of them. So let's start here, right? We've done this a million times in statics. So some of the moments, let's start at A, gotta be equal to 0. So we're gonna have 6 kip, it's gonna be -6 times its distance, which is 1. Then we're gonna add it to force CD times 3 to get its distance. So you get that force CD is equal to 2 kip. And then of course that tells us that force AB is equal to not 6 kip, it's equal to 4 kip, right? Just by, equilibrium, 4 kip. So now we can find the displacement, right? So using that displacement formula, let me write it out. This chair is low, but it stays low. Okay, right, displacement is equal to PL over AE. Force, length, area, elasticity. So we want to find the expansion, right, the change in length of AB and CD. So let's start with AB. Displacement of AB is equal to, so the force in AB we just found is 4 kip, so we can write that as 4. The length of AB is 6 feet, so let's write that 6 times 12 inches. So we want to keep it in inches because we're going to have the area in inches. So we're given 1.5 inches squared, and then elasticity, 17.4 times 10 to the 3rd. Right, so we can just keep it like that. Those units are going to work out. We're going to get that displacement of AB is equal to 0.0110 inches. All right, so now we need to find the displacement of CD, obviously. So displacement CD is equal to the force in CD, which is 2, times its length, and this one's only 4 feet long, so 4 times 12. The area of it is just 1 inch, and then the E is 17.4 times 10 to the 3rd. So you do this, you get that this displacement is a lot less, 0.00552 inches. Okay, so they have different displacements, right? So that means that it's going to kind of be at an angle, this rod AC, it's going to be at an angle. So how are we going to represent that in our math, right? Well, let's draw what the displacements look like. So here is point C originally, right? We can label that C, and then label this point A originally. So of course they're going to expand. So we know that CD expands 0.00552 inches. So it's going to be up here. This is going to expand, let me just say 0.00552, right? And A is also going to go that much, but A is going to go further. It's going to be about twice as far, I think. So this is 0.0110. Okay, so now what we want to do is let's draw a right triangle in between them, right? Something like this. And this is definitely not to scale, but this is a right triangle. And what's the height between them? Well, we know that they're 3 feet apart, right? 1 foot plus 2 foot, so this is 3 feet, or 36 inches. Now, where is point E? Well, point E was originally 1 foot here and then 2 foot here, right? So it would be a third of the way. So if we carry that out, it's going to stay here, where it's 1 foot and then 2 foot here. So we want to find how much E is displaced from here to here, right? What is that displacement? Well, it's going to be pretty easy to tell. So the displacement of E is equal to 0.00552, right? The displacement of C, and then plus this displacement, which is extra, but only 2/3 of it, right? Because this is on the triangle, so it only goes 2/3 of that way. So it's going to be easier to say, I forgot to write this, but this is literally half of that, so this distance is 0.00552 as well. So if you want to find the displacement of E from this line, it's going to be 0.00552, but 2/3 of that. We're going to add 2/3, 0.00552. Now we're going to get the math on this to get displacement of E is 0.009195 inches. Okay, so that's not our final answer yet, right? We know that D is displaced that far forward, but then we need to find this displacement of EF, that just last draw there. So that's gonna be pretty simple, right? Just the same thing we've done here. Displacement of EF is equal to, so again, force, so we know it's 6 kip in that line, so it's gonna be 6 times its length, which is 1 foot, but we need to multiply by 12. So 12 inches, 6 times 12 inches on the top. Its area is 2, and then its elasticity, 17.4 times 10 to the third. All right, where did I do the math? I definitely did this somewhere. Yep, there it is. So you get that this is equal to 0.00207 inches, and all I have to do is add these last two together to get displacement of F, not F. F is equal to this plus this, right? You add them together, 0.0113 inches. Wow, I cannot do that handwriting today. All right, there you go, that's your final answer, 0.0113 inches. So, right, it's just about doing each step individually and then doing that geometry, right? Remember, we've done geometry before, we know how to do it. That's how you have to complete this answer. So yeah, if you have any questions, feel free to check out my channel, ask any in the comments, and I'll see you in the next video. Peace.